Talk about various thermodynamic processes in this class. But before doing that, just to recapitulate from the first law of thermodynamics, we know that Q, the heat pumped in, is given as the change in internal energy of the system plus the work done. If these changes are small, we can also write the whole thing as dq equals dE plus dW. And we already know that dW is nothing but PdV from one of the previous classes. Okay, one more thing I would like to talk about is the PV diagram, the pressure volume diagram. So the pressure volume diagrams. Okay, so what are these? Well, these are the pressure volume diagram is like are the diagram that show how is pressure changing with volume. So let's say if you have an isothermal process, which means constant T process, temperature remains constant. If you look or you draw how pressure changes with volume, you will see that, let's say you have an experiment, you set it up so that you have the system sitting on top of a furnace. Furnace is maintaining a constant temperature of the system, and you change your pressure or you change your volume, and you will observe, and you do it very slowly, and you will observe that the pressure and volume, they follow this kind of a relation. And this is true. So, and this you can clearly tell the equation of this line if it is an ideal gas. For an ideal gas, we know it's PV equals nRT. So in a way, nRT is a constant. If your system is isolated, gas R is the gas constant, T is the temperature of the system, then we know it's going to be V equals a constant, PV equals a constant. Okay, so this is an isothermal process. Moreover, let's also calculate the work done by an isothermal system, and we can do that by simply using this PV diagram. So we know that the work done, dW, is PdV. So if you want to calculate the work done from going from V initial to V final, let's say this initial, there's an expansion going on, expansion going on, the volume is changing, let's assume that. So either there can be expansion or contraction. You can go this way or the other way around. So let's assume you are expanding. So when you're doing work, you actually are expanding. When you're compressing, which means work is being done on the system. So you go from a lower volume to a higher volume, and you can calculate this PdV thing by simply integrating from Vi to Vf, PdV. Now we know that P can be written as some constant which is nRT divided by V dV from here. And if you integrate that, you will see that W equals nRT Vf over Vi. Let's focus on isothermal process only in this lecture. So we already have talked about how the PV diagram looks like. We also talked how the work, what is the work done in an isothermal process. We can talk about other processes in the next class. So let's just make this one. and we can talk about other things in 2, because as thermal is sort of an important process which is encountered in day-to-day life, and we'll talk about other process in 2.